Welcome to the Oracle Autonomous Database Managing and Maintaining module. In this module, we will cover different tasks for managing and maintaining an Oracle Autonomous Database. We will be covering several topics during this module. We will start by going over how to manage users and privileges, followed by how to start, stop, and scale ADB. An overview of how to use REST APIs to manage ADB as well as Oracle Cloud Infrastructure. The next sections will cover ADB backups, using SQL Developer with ADB, and understanding ADB for experienced users. Let's get started. Let's start by understanding users in ADB. Creating a new user involves logging in as admin user and then issuing the standard create user Oracle database command. The minimum required to create a user is defining the user's name and the password. Once a user is created, roles must be assigned to the user. There are several predefined roles that grant a combination of individual roles to users. Users can still be granted individual roles such as connect, select, etc. But when granting roles such as DW role, all roles necessary to perform user-level operations are granted to the user. Users can also be created through front-end tools such as SQL Developer or through OCI calls as described later in this module. Let's see how to start and stop and scale an Autonomous Database. The Autonomous Database instance can be scaled on demand without tedious manual steps. Autonomous Database allows for independently scaling of compute or storage, resizing occurs instantly, fully online, memory I/O bandwidth concurrency scales linearly with CPU, so when CPUs are scaled, the system automatically adjusts other resources to match, stopping an instance on demand to conserve resources, starting an instance on demand. Starting, stopping, and scaling can be done by clicking through the console. See examples in the following slides, or through API calls, such as will be covered in the next module. To scale the Autonomous Database from the console, select the database to be scaled. This will place you in the database console. Select Scale Up or Down button. The scaling window appears. In the CPU count box, enter the number of CPUs you want provisioned in your environment. The default entry has the current value of CPUs provisioned on the environment. In this case, there is one CPU provisioned. So in this example, we scale the database up to 4 CPUs. You can also scale the storage in terabytes of database space allocated by updating the storage parameter. When the parameters are updated, select Update. And you will be placed back on the database console where the database will show as scaling in progress. Please notice that the color of the database icon remains green because database scaling operations do not require system outages. When the scaling is complete, the status will change to available and the CPU core count will be updated to the selected CPU count during the scaling process. To stop the database, select the appropriate database from the Autonomous console. In this case, there is only one, TestDW. This will place you in the control console for that specific database. Select the Stop button. This will place the database in stopping status, and when the process is complete, the database will show as stopped. Once the database is stopped, the button that was stopped is now Start. To restart the database, select Start. During the startup operations, the status of the database will be starting, and once it is fully up and operational, it will become available. Stop and start operations are relatively quick and are not depending on the size of the database or number of CPUs allocated, but are pretty consistent across instances. Let's look at REST APIs and Autonomous Database. For DBAs and developers that would prefer to interact with the Oracle Autonomous Database Cloud Services programmatically over REST rather than log into the Cloud Console and click through screens, Oracle's Cloud offers full REST APIs. This provides a mechanism for developing customized deployment and management scripts that can be saved and reused for deployments, set gold standards, and store entire application infrastructure stacks as versions of controlled code. The Oracle Cloud Infrastructure APIs are typical REST APIs that use HTTPS requests and responses and support HTTPS and SSL protocol TLS 1.2, the most secure industry standards. Calls to the Oracle Cloud Infrastructure using REST APIs can be written in popular scripting languages such as Node.js, Python, Ruby, Perl, Java, C, Bash, or curl. All Oracle Cloud Infrastructure API requests must be signed for authentication purposes. Oracle Cloud Infrastructure APIs are the ones used to interact with Autonomous Database. These avoid using username passwords and are based on the draft coverage HTTP Signature 08 specification for secure communication over the Internet. The steps to create and sign API requests are: form the HTTPS request. SSL protocol TLS 1.2 is required. Then create the signing string, which is based on parts of the request, followed by creating the signature from the signing string using the private key and the RSA SHA-256 algorithm. Add the requesting signature and other required information to the authorization header in the request. You will also need to generate an SSH key pair in the PEM format. This example creates an autonomous database in the Phoenix Data Center with a database name of ADATAB ASCDB1, the specified password, 8 CPUs, and 1 TB of storage. The response to an Autonomous Database API command, in this case a create command, will include the current status of the create process and other relevant information regarding the database being created. In this example, we see the database parameters such as the compartment or tenancy of the database display name, the name of the Oracle database, the current status of the database, the time of creation process, the number of CPUs allocated, the number of terabytes of storage allocated, the license model being used, and a direct link to the database console. In these examples, we see the basic API call for deleting an existing Autonomous database, starting and stopping an existing Autonomous database, and again, the result will be similar to what we saw in the previous slide. In previous sections, we saw how to scale the database from the console. In this REST API call, the database is being scaled to a total of 20 CPUs allocated. In the second example, a backup is initiated on the database. Now let's look at how to manage the database using command line. The CLI is a small footprint tool that you can use on its own or with the console to complete Oracle Cloud Infrastructure tasks. The CLI provides the same core functionality as the console, plus additional commands. Some of these, such as the ability to run scripts, extend the console's functionality. The CLI is built in Python, version 2.7.5 or 3.5 or later, running on Mac, Windows, or Linux. The Python code makes calls to the Oracle Cloud Infrastructure APIs to provide the functionality. These are REST APIs that use HTTPS requests and responses. To install and use the CLI, you must have an Oracle Cloud Infrastructure account, a user created in that account, and a group with a policy that grants the desired permissions. This account user can be you, another person, or a system that calls the API. A key pair used for signing API requests with a public key uploaded to Oracle. Only the user calling the API should possess the private key. Python version 2.7.5 or 3.5 or later, running on Mac, Windows, or Linux. Note that if you use the OCI installer and do not have Python on your machine, the installer offers automatically install Python for you. If you already have Python installed on your machine, you can use the Python version command to find out which version you have installed. The supported Autonomous Database commands using OCI CLI are: create, to create a new Autonomous database; delete, to delete an Autonomous database; generate wallet, creates and downloads a wallet; get, gets the details of the specified Autonomous database; list, gets a list of Autonomous databases; restore, restores an Autonomous database; start, which starts an Autonomous database; stop, which stops an Autonomous database; update, which updates the specified Autonomous database; and backup, which creates, gets, or lists backups. This example OCI CLI call creates the Autonomous database. Notice that variables are defined including all the parameters previously discussed that are required to create an Autonomous database. Then the command OCIDB, Autonomous Data Warehouse create with parameters is run. In this slide, you can see examples of calls for some of the other supported OCI CLI commands that were previously described. The format is always the same, starting with the OCIDB call, then specifying the database service, In this case, Autonomous Data Warehouse, followed by the command and parameters and associated variables to run. Now let's look at backup and restores for Autonomous Database. Autonomous Database automatically backs up your database for you. The retention period for backups is 60 days. You can restore and recover your database to any point in time in this retention period. You can do manual backups using the Cloud Console, for example, if you want to take a backup before a major change to make restore and recovery faster. The manual backups are put in your Cloud Object Storage bucket. When you initiate a point-in-time recovery, Autonomous Database decides which backup to use for faster recovery. You can initiate recovery for your Autonomous Database using the Cloud Console or the API call. Autonomous Database automatically restores and recovers your database to the point in time you specify. From the Autonomous Database console, in the lower section under the Backup section, a full list of all the backups that have been taken on this instance is listed, going back up to 60 days, which is the retention period. To restore from a backup, from the Database console, from the Actions drop-down menu, on the top left, select Restore. This will bring up the Restore prompt. In the Restore prompt, select Specified Timestamp or select Backup to restore to a point in time or to restore a specific backup. Select a backup from the list of backups. You can limit the number of backups you see by specifying a period using From and To calendar fields. When the appropriate backup to restore from is selected, proceed by clicking the Restore button. When the restore operation finishes, your Autonomous Database instance opens in read-only mode, and the instance details page lifecycle state shows Available, Needs Attention. If the restore point you specified was correct, and you want to open your database in read-write mode, click Stop, and after the database stops, click Start to start the database. After stopping and starting the database opens in read-write mode. In addition to automatic backups, Autonomous Database also allows you to take manual backups to your Oracle Cloud Infrastructure Object Storage. To perform manual backups, you need to define the Oracle Cloud Infrastructure Object Storage credentials and your Oracle Cloud Infrastructure Object Storage tenancy URL. You also need to create a bucket to hold the backups. The manual backup configuration tasks are a one-time operation. After you define your credentials and your tenancy URL, you can initiate backups without doing the same operations again unless the URL, the credentials, or the bucket change. For example, while connected to your database, to define your backup bucket, run the following commands. Set the database default bucket property to your Oracle Cloud Infrastructure Object Storage tenancy with the altered database property set default_bucket equals bucket name. If you have not already defined the credential for object storage access, such as staging and loading data into the database from Object Store, you will need to create a credential for accessing the Object Store. Object Store is the location where the user-identified backups are stored. In this example, we create an Object Store credential named defcredName, and we set it as the default credential with the altered database property set command. To create a manual backup from the Database Console page, select Create Manual Backup. When you click the Create Manual Backup, the first time you will have to provide the name of the Object Store bucket you created on the previous slide. Then proceed with the backup. Again, manual backups are not required or necessary since Autonomous Database automatically performs daily incremental backups of the database. Now let's explore Autonomous Database using SQL Developer. Oracle SQL Developer is a free integrated development environment that simplifies the development and management of Oracle Database in both traditional and cloud deployments. SQL Developer offers complete end-to-end development of your PL/SQL applications, a worksheet for running queries and scripts, a DBA console for managing the database, a reports interface, a complete data modeling solution, and a migration platform for moving your third-party databases to Oracle. For DBAs, the DBA console provides a GUI and step-by-step guide for many DBA tasks commonly performed. SQL Developer behaves exactly the same for Autonomous Database as it does for any other Oracle database. The nature of the Oracle Autonomous Database is to automate and simplify many DBA tasks, and so many DBA tasks may be disabled when using SQL Developer for administration purposes against an Autonomous Database. These are account permissions, restrictions, and not SQL developer restrictions. The following slides provide an overview of the most common DBA tests performed with SQL Developer against an Autonomous database. Connect to the Autonomous database with SQL Developer as described in the previous module, with the admin account, or another account if admin is not authorized, but note that some commands are privileged and may not run. One of the most common questions around Autonomous database is which database options are enabled and which are not. To answer this question, run the following command in SQL Developer and examine the output in the query results box, lower right. Select star from V$ option. To perform and view DBA operations, from the View dropdown on the top left of SQL Developer, select DBA to go into DBA view mode. Once on the DBA view, click on the Connections button, the green plus sign, and select the defined connection to the Autonomous database. If you have not defined a connection, go back to the Connections view and define one as described in the Connectivity module. Once connected, open the selected connection, in this case admin high, and then open up the database configuration. Then select Initialization Parameters, which will list all the Oracle database initialization parameters and what their corresponding settings are. Further down in the Database Configuration section, select Services, which will list all the connection services defined for the Autonomous instance you are connected to, and by selecting any particular one, the properties of the service. To view which database features are in use in the current running instance, select View Database Features Usage from Database Configuration Options. This will list in alphabetical order all the database features and whether they are currently used or not. You can always sort by column and value in the results set as needed. To get detailed information about workloads and performance, under Database Status select Instance Viewer. This section shows top SQL usage, memory and storage usage, processing running, sessions, and other important information about the current workload on the database. To view which is the active resource plan on the instance, for example, to determine whether this is an ADW or an ADP instance, select the Settings option under Resource Manager. In this case, the active resource plan is OLTP plan, indicating it is an Autonomous Transaction Processing instance. Any information related to users, roles, privileges, and more will be under the Users section. In this case, we have selected Users under the DBA view and then selected the admin user. On the right-hand screen, you can see all the information about the admin user. Here, we selected Roles, and you can see all the roles that have been granted to the admin user. You can view this information for any user in the Autonomous database. Notice that when you click on users defined that are locked, for example, the GG admin user, that would get used as part of the Golden Gate implementation, but by default are locked down in Autonomous database. To review storage information, select the Storage section. Note that although we will be able to view storage information about the Autonomous instance, storage is automatically managed by Autonomous database, and these parameters are allocated, but storage cannot be changed by the user or the administrator. Let's look at Autonomous database for experienced users. Autonomous database configures and optimizes the database for you. You do not need to perform administration operations for configuring the database. SQL commands used for database administration, such as create table space, are not visible in this service. Similarly, other administration interfaces and utilities, such as RMAN, are not available. The default data and temporary table spaces for the database are configured automatically. Adding, removing, or modifying table spaces is not allowed. Parallelism is enabled by default. Degree of parallelism for SQL statements is set based on the number of OCPUs in the system and the database service the user is connecting to. Compression is enabled by default. Autonomous Data Warehouse uses hybrid columnar compression for all tables by default. You can also use different compression methods for your tables by specifying the compression clause in your Create Table and Alter Table. Autonomous databases use Unicode AL32 UTF-8 as the database character set. Oracle Database Results Cache is enabled by default for all SQL statements. Changing the result cache mode is not allowed. In Autonomous Database, direct access to the database node and the local file system are not allowed. Database links to other databases are not allowed for enhanced security. Database links from other databases to Autonomous Database are allowed. Calling PL/SQL programs using database links is not supported. Parallel DML is enabled by default. If you do not want to run DML operations in parallel, you can disable Parallel DML in your session using the following SQL command. Alter session, disable Parallel DML. Autonomous Database configures the database initialization parameters based on the compute and storage capacity you provision. You do not need to set any initialization parameters to start using the service, but you can modify some parameters if you need to. Because Autonomous Database is automatically managed, some initialization parameters can be changed and some cannot. In this slide are listed all the parameters that can be modified in Autonomous Database. Many features of the Oracle database are restricted or removed from Autonomous Database service for several reasons ranging from providing an optimized environment to risk of security breaches. Please note that this list is a point-in-time list and restrictions may be added or removed as the Autonomous Database service evolves. If an application that is being considered for migration to ADB, or if you intend to develop an Oracle database application with any of these features, be aware that they may not work with Autonomous Database. In this slide is a list of all the features that are restricted or removed from Autonomous Database. Many SQL statements used for resource management in the database are not available in ADB because these functions are managed automatically by the Oracle Autonomous Database. If you run a command that is restricted, you will get an ORA 01031 insufficient privilege error message. The statements that are not allowed are administer key management, alter profile, alter tablespace, create database link, create profile, create tablespace, and drop tablespace. The create table and the alter table statements have clauses that are not allowed. Most of the clauses relate to storage and index management, as these are automatically managed by ADB. If your database application uses any of these clauses, they will not work and need to be modified. Several data types are not supported in ADB, including long raw, media types, and spatial. This is a point-in-time restriction and may change at any time. Several alter statements and create user statements are restricted as well. Please refer to the list on this slide. Here is what we covered today. We started out by going over how to manage users and privileges, followed by how to start, stop, and scale ADB. We then had an overview of how to use REST APIs to manage ADB, as well as Oracle Cloud Infrastructure to manage ADB. We then covered how to do backups in ADB and how to explore ADB with SQL Developer. And we finished off by understanding ADB for experienced users.